Good morning, Namaskar. This is Suraj Singh speaking of Bharat, India. Everybody, I last time talked to you about formula on axle or on expression, and this time continuing that one. Last time I think it was 29th, and now again I'm have to develop some more shapes and combination of shapes. It's very important. Various combination of shapes. I'm going to talk to you, and I think you will like this because last time we discussed about various equations, as this you can see from here. Various equations we discussed last time. And we also discussed various formulas and combinations. We talked of square, rectangle, then equilateral triangle. Then we talked of isosceles triangle, right angle triangle, circle, sphere, cylinder, cone, parallelogram, then rhombus, and then trapezium 1 and 2, polygon regular, that is 5-sided, 6-sided, 7-sided, 8 sides, 9 sides, 10 sides. And then we talked of various combinations, that is combination of triangle, ordinary with circle, and then combination of right angle triangle in square. And then we talked of combination of triangle in parallelogram. This was app 24. We could not go further. I am now on app 25, that is combined right angle triangle in isosceles triangle, teeth out right angle triangle. I like to show first of all this what I'm going to talk. We're going to talk about this. You can see this first of all this figure. I'll just blow it up so that you can see it better. This is that one, means here is the right angle triangle. You can see here there is another triangle, that's isosceles triangle here. Isosceles triangle means there are two angles which are equal, and two angles are equal, two sides are equal. Sum of these three angles is 180, and remaining angle is there is one right angle triangle in that. And on to hypotenuse, we have right angle triangle here, right angle triangle here, right angle triangle here, and right angle triangle here. This is a combination of this as a triangle in teeth shape, so this looks like teeth, This looks like teeth, and there's a cut in. So there are 5 right angle triangles in this, and one isosceles triangle. We are going to talk about this. So we have here requirement of one right angle triangle formula and isosceles triangle formula. That's requirement here, and that requirement is like this. We say combined right angle triangle and isosceles triangle, teeth out right angle triangle, and this combined right angle triangle and isosceles triangle plus teeth out this title. What we say, subtract right angle triangle from isosceles triangle because it's a cut in there. So you can say here this area of one right angle triangle subtracted from this isosceles triangle area. That's one requirement. Then what we need for that, we require isosceles triangle and right angle triangle formula. And because here isosceles triangle is bigger than right angle triangle, so that's what we have, isosceles triangle formula here, right angle triangle, the combination of these two, and we go to combination of this totality. This is a little, we see the isosceles triangle says, we just copied this formula from already we have. We have copied that both sides are equal. We can say both sides equal, base different, and base is here, BH is meters, height. Area we know half into base into height, that's very easy. Half into base is the height, base is C259. C259, height is 15, so D59 here we get area. So we can say here, now we have to find perimeter. Perimeter means we have to take sum of these one side, two side, three sides. Hypotenuse, we don't have base and height. We have to find hypotenuse, and we already solved that hypotenuse. The parameter is called base plus twice hypotenuse h, and this is the one hypotenuse formula is here. Half base square, half into base square plus, that is hypotenuse plus base square. Base over 2, this hypotenuse to find half of base square plus height square under root, because it's half here for this find it, because it's right angle. Now we have to find this, so we can add some. So we did that. Now we say now 3D we calculated, 3D the volume we calculated, and we 3D surface area we calculated already. This application of isosceles triangle, application of right angle triangle, here base we have, perpendicular P we have, half into base into height, we can say half into base into height. Base is C6 here, and D is here. You can find that this hypotenuse also where to find, because same way we can say here, we find hypotenuse here, and base sum of these three, base plus hypotenuse plus perpendicular. So we got this 3D vertical volume and 3D surface area. So we have already these two formulas. What we have to do is to combine them. Combination according to this requirement, and that requirement is cut out or subtract one right angle triangle from the isosceles and add 4 these and deduct this one. We have to be careful about this, that with this portion we have this is a cutout here also. This base of a right angle triangle take out of this is the same portion of isosceles triangle we have to take off. So move on to this. We can say now what we call it. Now we call it, this is individual application, this individual calculation, but now we have to go to combined calculation, which is very important. Our objective is combination of isosceles triangle and right angle triangle inside reduction and addition of 4 more triangles. That's what we are going to do here. This is calculation sheet now. Thanks, Mr. Surendra Kumar Goswami. You're welcome. Now, what we say that combination has a question. We say isosceles triangle area 1. Let us say area is named 1. Internal right triangle area 2. External right triangle area 3. External right triangle area 4. External right triangle area 5. External right triangle area 6. So 1, 2, 3, 4, 5, 6. And we have here how many areas? We have here, you can see 1 area, 2 area, 3 area, 4 area, 5 area, 6 area. We have 6 diagrams here, 6 figures here. So we say we have already all these. We say E to 59. E to 59 is here. E to 59, you can say this area we have, so we just link here. We don't need work on this again. Same way, 2 we have internal right angle triangle 2. That's E to 62, and this is E to 62. Here it is. So we have this. Similarly, external right angle triangle 3, same. We got this in combination of these areas. That is, how to combine them. We have to say C264 here. The C264, which is isosceles triangle, that's a plus, and we have to deduct 1 from here. So we say deduct 264 here, and then add E, F, G, and H. E, F, G, and H. So we got this area, which is combined area of these shapes. Now we have to find this. One part is solved. Now we have to go to parameter portion. Now what it says, parameters are a little complicated in this case. Not that is as a thing. It's not so direct sum up. There are cutouts in parameter. As I told you how these cutouts are. You can see these cutouts are here. For example, this is a triangle diagram here. This is a parameter, but there's a cut in here, or deduction is here. Same way, this parameter is okay, right? But here is a problem. And also in these 4 right triangles, there's again reduction of basis. So basis is a 1, 2, 3, 4 basis, and also basis for this. So there are so many cuts in there. So many deductions are there, that we must understand and see. So what we do, we say, no, parameter we are talking, triangle parameter minus 4 into basis. Actually, when I say triangle parameter, actually it is isosceles triangle. So it's written there isosceles. I think there's some understanding about this isosceles triangle actually. Isosceles triangle parameter, that's given 1, minus 4 into basis. 4 basis, I just told you, minus we have to do that, plus internal right triangle, that is to be cut out. Means parameter shall not cut out, it will be added in fact. Internal right triangle parameter plus 4 into external right triangles parameters minus 4 into those bases. Got these 4 requirements here. This is very important fact. You have to understand that. It says, according to this figure, once again I show you this figure so that you may not be confused. This is the figure. It's a small one, teeth one, but there are requirements of additions and subtractions from parameter. While there was no problem as far as area was concerned, we deducted only this portion. We already deducted that one. In this case, parameter this, again I say total parameter of all these, minus this, this. We have to do it twice. Base for this and base for the next thing. So what we do here, the y say, right? So again I say this equation that we plotted in here. There's a plotted bigger one. The bigger one that goes off this. So isosceles triangle, again I say isosceles triangle parameter minus 4 into basis plus internal right triangle parameter plus 4 into external right triangle parameters minus 4 basis. This is what we have to understand. So what we do now? Let's say isosceles triangle parameter. Now we name it 7 has been named up to have 6. We take number 7, say it's named as 7. I'm taking this as a name, it's not number. So 8 is, let us say isosceles triangle, then we say internal. In this equation we are saying isosceles triangle parameter minus 4 into basis, that's the meters. Again we say internal right triangle parameter, that's named 8, and 4 into external right triangle parameters minus 4 into basis, that's named 9. And we say then combination of these parameters is sum of 7, 8, 9. So these three factors we have to work out fast. These three factors we work out, we can sum up them. So what is that? Let's say I259. This is the base plus twice into hypotenuse. So we have isosceles triangles parameter. That's say minus 4 into C 5 to 59. 4 into 4 is number. So C 259. This is that B. So what we get? You get it, base it is, so we deduct, so we get here this requirement number, here we get number 7, then internal right triangle parameter 8, it is direct one, and we can say right triangle is here, its parameter is where, we have to see where's parameter here, and parameter here is, if you see where's parameter, this is parameter, base plus perpendicular plus hypotenuse, base plus perpendicular plus hypotenuse, so this is that one. You can say base is 262 plus D62 is perpendicular plus F262 is hypotenuse. So we add these two and that's linked here. This is here, you can say 262. This is G, this answer here. So we got the second one, we got it. So this name 8 is over. Now 4. Now we say, I'm sorry, it's just jumped in, I don't know why. I 25, yeah, that's there. So let me put this back a little so that it doesn't disturb. Alright, okay, now we got here. So we say we have to find out now. This we solved. 4 into external right triangles parameter minus 4 basis this time. So 4 into external. 4 is there. External did G62. G262. This is that. G262 base plus this is that. Okay. That's what you say. Let's say 4 into that minus 4 into C262. C262 is 5. So we have to deduct that as well. So we get the solution here, number 9. So we have sum 7, 8, 9. So sum 7 is L264 up to N. We get this answer. So we got the parameter required. We got this answer here. Now we go to parameter. We got this parameter answer. Now we got 3D vertical volume. So we got areas here. In this areas we got area. We got here combined area. One is this one. So this is a combined area. You can say this. You can just put in like that. So this is combined area. Is combined parameter. This is combined parameter. We got superficial answers. Now we are going to get 3D superficial. I'm saying because surface area we have got 3D we are talking of. 3D is because 3D is ultimate requirement for solid geometry or solid figures. Now, why are you saying this? 3D vertical volume, cubic meter, we know. Cubic meter, I say isosceles triangle volume, I name it 10. Internal right angle triangle volume 11. External right triangle volume 12. And external right triangle volume 13. So there are 4 triangles. So 12, 13, 14, 15. Area is same, volume is same. We're just naming them for purpose of calculation. So combined volume is equal to 10. 10, this is 10 minus 11 because we have to subtract this and then add this one, this one, this one, and this one. We'll get combined 3D. So we say this already we got L to 59, L to 59, C to 59, L to 59, L is here, and area H, and say L to 59 volume. Yes, this is volume meter cube per cubic meter. That's end area into H. End area, when I say end area, it is 2D figure, that is isosceles triangle. Let's say 2D it is isosceles triangle. Means end area is one other side. When you extrude it in 3D, there will be 2 ends, and 2 end area into H we say volume. If you say volume, if you take this area and just extrude it, extrude means give us vertical height in 3D or ZX or whatever it is, it is 750 then in that case, because this is area 75 here. So L 259 we say, L 259 it is already worked out. Internal right angle triangle volume 11 is 200, and that is from IJ262. J262, that's also end area into depth. So that's to be deducted. And here again 12, that is J262, J2 same thing, but because one is addition, this are same J262, D62. So what is combination is C266 is here, C266 minus D266 plus this plus the sum of E262 sum of this 4, we say EFGH. So we got combined volume, 3D volume 10 minus 11 plus 12 plus 13 plus 14. Now let's go further for combined surface area, not volume, surface area, and that is again same formula we apply in this case in different way, because the surface area is what to do, isosceles triangle perimeter minus 4 into basis into depth, because 4 into basis is perimeter, into depth plus internal right triangle perimeter depth into depth plus 4 into external right triangles parameters minus 4 into basis into depth. So this is, you can say, a kind of volumetric calculation for surface area. You can read again. It says isosceles triangle perimeter, just take it minus 4 into basis, because there's a cut of 4 right angle triangles attached on both sides of hypotenuse, both hypotenuses. So isosceles triangle perimeter minus 4 basis into depth. So depth, it doesn't mean volume, it's in the area, plus internal right triangle perimeter means this is internal right triangle perimeter into depth plus 4 into external right triangles parameters minus 4 basis into depth. So this all we have to track in here. It says isosceles triangle perimeter, let's say 7, as we give same name as 7 here, minus 4 into basis into depth. So that is one we kept for isosceles triangles. That is triangle perimeter of 7 minus 4 into basis to depth square meter. Other one internal right triangle perimeter 8 into depth and the square meter, and 4 external right triangle perimeter minus 4 basis, that's 9, and combined parameter of this 7, 8, 9. Same way you can say L and K, L to 64, L to 64 is here of isosceles triangle. So we use that one with depth. K259, K259 you can say here, K259. So same way we are using here, and it's summing up here. So this is what our combined calculation of these six areas, 6 figures in 3D is completed. I think God is little tedious, but you have to keep calculation in mind. And we go to up from 6 as combined 5-sided polygon, pentagon constructed around square, and you see its shape here is this one, This time is saying this is a square one here. We fix pentagon around on 4 sides, and we see real figure here. This is cut out here with bases, and if you see, it's a kind of different type of shapes. Means we combine 2 figure square with locations of pentagon on sides, and this is in a kind of decorative geometry. I can see even you can construct building design like this if you wish. That's where we are moving out to. Now is that one combined 5-side polygon, that's pentagon constructed around square. This pentagon is square, so we put one pentagon around each side, and so combination is here. So what's requires here 4-sided, add 4 5-sided pentagons. So we have 5-sided pentagons, 4 number, and we have also 5-sided pentagons. Squares, base of square bigger than 5-sided pentagon. So what we require is, we require 5-sided polygon, that's pentagon plus a square. These two requirements are here, which is here pentagon, so that's square. And we say add 4 5-sided pentagons to square. This is what we have to add. So we have 2 formula requirement now. One is polygon pentagon, this formula is that one, and we have then this formula is there. Then we have square formula, which is here, and then we have the combined calculation. Now we have this already done, polygon already done. We have here its area, total area of 2D, 2D, yes, not 3D, planar area you can say. We have planar area, and we have here formula based area, same, both are. And then we have depth, we have parameter here, and of course we have volume in 3D here and volume in 3D here. All this, this is surface area in 3D here. This we have here, so volume we can just highlight it for our purpose. So we got in this. Now we go to square. Same applies to square here. We have here various parameters of square. This is parameters area, it's height to depth you can say, and here it's square area, volume meter cube, and this is area surface square. So we have surface area. So we have square and polygon, which are to be combined. So we can now stay here. If you see here, combined calculation, which is in these cells, combined calculations. That's polygon. How many polygons are there? 4 no polygons are there. So polygon 1, polygon area 2, 3, and 4. You keep like this. Area is same, of course. This is I275, and if you see this I275, this is here. So the area, and this is 277, I277, and that would be something else. So let's do this. I275, polygon area 1, area 2, area 3, area 4, and total polygon area is sum of these 4. Square area now, let's say it's polygon area now. Square area, now we take a square is 2562 280. This is D280 cell, area is square. We have this area, total area is how much? This area, polygon area plus this area, and that's this one. We got total area. Right now, yeah, that's right. We can even download it so that it doesn't confuse. So area, total area of polygon, 4 number polygons, and 4 number polygon is pentagons plus 1 is square, this one. Now surface area of one polygon, that's meter square, is 1 into polygon into base into depth. I mean to say 1 polygon base into depth. Polygon base into depth is A, surface area of 3D, and surface area of polygons is that one. So we have to, because surface area and volume we are going to find. So I mean, let's start this the one. Surface area for 1 polygon meter square minus 1 polygon base into depth. We have to be very careful about this because here there's a cut in, just like here, base of polygon gone as well as this cut is square. The two losses, side of square we are losing here, we are losing here, we are losing here, and we are using a polygon, pentagon base as well. So there are double losses here. We have to take them into our perimeter surface area and 3D surface area to count them, because it isn't going to impact the volume. It isn't going to impact the volume because it's connected one, so the volume won't impact. Volume is not impact now. So there's one, that's surface area of polygon, 1 polygon meter square, and it's 1 polygon, 1 into polygon, and that is the base, 1 base of polygon to depth. So this is net area of 1 poly surface area of pentagon, and surface area of all polygons, number 4 times of this one. This we named A, so this is a 4T, we have taken like this here. I277, I277 is here, and deduct and plus 277 this, and that is C277 is here. That's per meter into F277 is height. So I get his here. This is, we got actual area, and here we multiply by 4 because we have 4. Now what is parameter we calculate here, the 3D volume we calculate here. This is what we calculate by here. I think maybe you're not getting easy understanding, but it is a complicated one, but it's very much required. It's very much required here. You can't see that it's immediately understood. You should have a clear picture in mind. Only then you can say. You must have clear mind in this. Only then you can say is this or that. Now I say better I take a parameter consideration, that is polygon parameter 1, polygon parameter 2, polygon parameter 3, polygon other names are there 4, and polygon parameter total, that is similarly square parameter here 4 polygons. So we get really say polygon parameter 50 size C277 is here. Then again C277, because we are taking each separately. So 4 polygons are there, 4 polygon organs for pentagon. I am saying polygon because it's polygon, but it is actually pentagon. So it's pentagon, so it's okay, fine. You write polygon, you write pentagon. I can write pentagon also for convenience, so that there may be no confusion. Pentagon, it applies for all, and you can say same thing, and we get sum of these, sum of C282 and 2F8. We got some here. Square area, this is D280 and D280 is here. This area we have square. Total area is this is square. This sum 282 and 482. Sum G282, 282 is here, and this plus this is this one. The surface area for 1 polygon, that is meter square minus 1 polygon, base the height, same thing as we did there, we did here, and that's what it is done. Surface area for all polygons is this, and that's what we do. Now this parameter we found, and we got surface area we got, total perimeter we got here, and we say that is perimeter 1, perimeter 2, perimeter 3, perimeter 4, polygon perimeter is this, and square perimeter is this. So we total parameter is this. Total parameter surface area of 1 square minus 4 polygon basis into depth B equal to B, we calculated this surface area for 1 square equal to this, and we say, so this is, this is for surface area. So we got surface area of this combined figure. We have so many deductions as well for square basis and polygon basis. So this is, we have to be very clear. In perimeter, particularly in surface area, there's deductions, but in solid geometry, in volume, sometimes there will be reduction, sometimes addition. In this case, there is additions of all this volume, but surface area is deducted. That's an important point here. And this is the volume, you can say. You see all this sum for 4 volumes are there. We have got this volume G277, and that is here G277. This is volume. This volume is here, and we take this volume here, and this goes all with the sum of these 4. And square volume is this. So we add this square volume 1, and this one, we get this total surface area square. This we got this volume, So you can say there's 1 here, this is surface area, and there's 1 here for volume. This is our solution for this complicated calculation. So we got to 27. I'll take you 27. I'll also show you 28. 27, first what diagram is. Diagram is that there's an isosceles triangle. Based on that pentagons 3 number. That's one question. And then 28, which is also geometrically oriented. It's the one you may like or not, I don't know, but this is actually cut out from octagon. This is octagon, and there's hexagon in between, meeting at same base, and then we clear it. This is a cutout of that. The final shape of that different type, and then it's also other one, and that is 28, I think 28, and then 29. It is 29, and that's here. In which case we are just doing one octagon minus pentagon. We're doing this in this case, and we are doing 30, and that is little different, kind of 10-sided. This is 10-sided, and this another inside 8-sided. This is 10-sided, this is 8-sided, and we cut it, deduct it from that, and that's what we. And also we can say one more. That's 31, and that is it's an assembly of parts. You can say there's one isosceles triangle here, and there's a pentagon here, and there's an octagon here, octagon here, and again pentagon here, octagon here, like this. So this is final. So these additions only, and this we will discuss. So we'll go to 20. I think we were discussing something here. We discussed this one just now. Which one we discussed? We discussed now. We didn't discuss that. We discussed the other one. We discussed the isosceles triangle, and no, we have not discussed yet. Also this. We discussed this. Yes, I think square and square. Yes, we discussed this one. So now we are here. We bye-bye to this one. We say bye-bye with bye-bye, and we go to this one. F27. Combined 5-side polygon, pentagon constructed on isosceles triangle. So this is a kind of, you can say, addition system. Here is this. So just added to these 3 corners each pentagon. Not very difficult. There's no confusion in this because it's only simply additions. Well, this is this kind of geometrical calculations, and easy. It takes time, but now because we formalize them, it's easy for us. So what we do now, we carefully see once again this diagram, this figure here. I'll just break down. I'll just draw it up, and you can see various designs are shown there. Everything is shown there, and this is what we do. So here, what we do. Let's start on this and say what actually we need. In this case, we need 3 diagrams of pentagon, 3 sides, 5-sided pentagon, and we need isosceles triangle here, The polygon located on corners of isosceles triangles, certain polygons located on on corners of isosceles triangles. That's according to these combinations we see now. Now we got polygon, this five-sided formula here. Now you just that is formula I keep put from there. Now this the formula is up to here. This one means directly we put from our previous work. And also the isosceles triangle here from previous work. So this diagram as well as this is also copied from there, this pentagon and this one. And we also now go for combined calculations. And so we have complete same details. We need not worry about past one because we already studied that. So what we have from there, we have area and we have volume from area from here, and we have, we have this 3D calculations, depth we have, and this volume, and this is 2 polygon surface area we have. So we have this here. So for isosceles triangle, we have similarly here. We have volume and we have surface area. So there we have both for linking purpose. So what we need actually is we need combinations. This is combined calculations. This is our combined calculation for these two entities, these two figures of pentagon and isosceles triangle. It's really supportive if you are analytical person. Well, I'm not saying you're not, but it requires some attention as well as concentration on this because it's a formula, and even if a small error can lead to multiplication of errors. And that's where we have to be careful. Being a calculator person, maybe an engineer or someone else you are, or you are a mathematician. It doesn't matter, but just because once you work on this, it becomes a tool for you for other assemblies. That's where we are interested in. I should not do same work again and again just for sake of working. My work should be done once, and then I should be having enough reference, you can say. It can be called a reference. I can use this reference for future activities if similar kind of calculations are required. So now it's a combination, and I say, as I said, that there are 3 polygons or 3 pentagons on one isosceles triangle. So let us see now what stays. Polygon area 1. Polygon, I should say, polygon area, pentagon is one same thing. So I can also write pentagon here for purpose of clarification. Pentagon here. I write here pentagon. So this is pentagon area 1, and here also the pentagon area. Pentagon, I think I should write this polygon and pentagon like this, just for pentagon here. Okay. Pentagon 1, area 1, pentagon area 2, and then 3. We have 3 combinations with one isosceles. Polygon area square. This we have this I295, I295, I295. That's here I295 here, and we have got here. So we can see directly we link this one. Add up here sum of these 3 kept area of polygons. Now isosceles triangle, that is E300. E300, that is this one. I get half into base into height, and then we have the total is this plus this. You can say F302, F302, F302 here, and G302 here. This is added, and we get this area. So that's one part. Now we say parameter polygon 1 here, polygon 2 and polygon 3 and isosceles triangle. We have from previous calculation C297, that's okay 50, it's okay. And then again 1, 2 and 3 for all same lengths, and isosceles triangle is 41, and that is I300. Let's see how this also parameter. So total parameters, this we got this answer, total parameter. This parameter, remember the surface area to work out. So we got total parameter. Now we got here vertical volume, 3D, that's So again, this volume 1 this is volume 3D volume for 1 figure, 2 figure, 3 figure. We add up and we say G297, G297. This is that one, G297, volume of polygon, and it's okay. We got volume of polygon, then polygon 2, and polygon 3, and the sum of these three, we got total polygon volume, cubic meter. And isosceles, and this is isosceles triangle, L300, L300, which is here, and this is 750. कौन आ गया? Hold on, please. हाँ? कौन है? फिर जाना नहीं है? नहीं जाऊँ क्या? हद कर रही है अंदर अंदर। ठीक। Okay, now we continue. Sorry for disturbance. So I said that combined calculations, I say this, we have 3 and we got, this is sum of these 3 and we got it here. Isosceles triangle, we got L300, there's L300, and this we got here. Now surface area we have to see, and that's important. We got already I297 here. We got already, and that's here. Again, the second and third, and total polygon surface area is this. Who is this man person? I don't know who's this disturbing person. Who is this? What's coming here? Unnecessarily disturbing. What does it know? Well, see, I say we got total here, polygon 1, polygon 2, polygon 3. We got I297 here, again I297, and we got these 3 sums up here. And isosceles triangle is this, that is here, that is in M300 area, isosceles triangle area. So we got total area here, that's some M304, and this, we got this area. So we solved this figure also. We have got now complete requirements of this because it's direct sum up, so there was no major problem in this. But this is method. We had this method. We have to understand method. What method is there? So we got this one right. Now we go to app 28. That is, as I showed to you, this one cutout of hexagon from octagon. Hexagon from octagon, that is combined six-sided polygon pentagon constructed 8-sided pentagon polygon. That's the arrow here, so 6-sided hexagon. It should be, I'm sorry, then it should be 6-sided pentagon, hexagon actually. Hexagon, this is hexagon. This is, and this is error in writing, so this is hexagon. So 8-sided, so this hexagon 8-sided. So there's a correction which I did because it happens. So we get now what to do. Combines, subtract from octagon a hexagon, says subtract from octagon a hexagon, require 8-sided polygon octagon and 6-sided hexagon. Hexagon to be built into octagon means this hexagon is to be built into octagon. This hexagon is to be built into octagon, and this means this is our figure, kind of you can say nut or a spanner, you may say a kind of mechanical spanner. I'm just saying that kind of, not exactly. So I say here a regular polygon regular, and that is here we transfer formula, we copied formula of 8-sided figure, that's regular, and that's called octagon, and that is from here to here. Other one is not from here to here, here to here, yes, that is 8-sided regular polygon, which is named octagon, and then we say other one is six-sided, that's hexagon, and that is from here to here. So we have two copies here. One is for octagon and other one is for hexagon. Both here we have, and now we have to use them for purpose of combining them into this one, and that's called, combined calculations of these two. So combination says what actually we do. We need areas and let us say octagon area 1, hexagon area 2, and we say why consider one octagon full and the next one 2, and we take these areas J313, and that is here J313. We got area here already, and for hexagon we say I320, and this is the one I320 is here. So we have these two. We have to deduct hexagon value from octagon because this inside and deducted and is cutting it, so taking out, so we got this answer deduction. Now this is for area now, parameter of figure, parameter name 3, this was area in 1, 2, now this name 3, and this is C315, that is there, this is side, and we deduct 312, D312, and this is D312 because this is one has gone here. If you see in figure here, this one has gone, so we have to deduct that one here. We do that, and we got this. So then hexagon parameter 4, now we're talking 4, parameter minus one side, same thing we have to do here in both cases, and we octagon we deducted 1, and also in this we got 1. We got sum of this. I mean 3 and 4, this is parameter 3 and 4, we got parameter of this. Now we go on to, we got area and parameter by taking out those cutting or reduction or deduction, what we call it. And we are going to volume, 3D volume, surface areas and volume both. Now solid volume is octagon, we are talking volume is cubic meter, that's here. G315 and G315 is here. G315 is already volume we have, and we have this volume here. Hexagon volume we have here, and that is, hexagon volume is, this is G322, and this we have, hexagon volume. So net volume is, this minus this we can say, 326, this is this one, F326, D326 minus, we got net volume. So volumes of solid we got in here. Now we are going to find about surface area of volume, surface area of this 3D, where sides impact upon those two sides which are removed, these impact upon. So I got 3D surface area is octagon, surface area is square meter, surface area of octagon. Go to all octagon surface area, whatever you calculated, to deduct from that's a minus hexagon and areas, minus side into extruded. So because we are going to find surface area and we lost all this area in this figure, we are losing all this area. So we have to accordingly, also this side, so that formula we are taking here. So it says that I315, so I315 is total. I315, this is total area minus hexagon and areas, that is D312, that dimension, D312, and that is for that one, D312 into 315, and that's this one, depth, you can say, minus 2 into 2 are there, 2 ends are there, and I320, this is this one. So that is top trapezium area, and this is some combination of total ends, and that's what we say. We got in here, and this octagon, and for hexagon, surface area, sides of 5, although 5 sides actual height of 5 sides of the extruder height, not 6 sides because one side is gone. So total surface area of combination is this plus this, and we got it. That's what's important here. So we resolve this deduction. We resolve this deduction of hexagon out from exit from octagon, and this shape we got in answer. Okay. Now we go on to 29, and that's here, here there is deduction of pentagon from octagon. Pentagon is deducted from octagon. So we can say combined 5-side polygon, pentagon constructed within 8 sides, or the construction of this within direction, same thing here because it's out. So let's say how it works. How it works, we have to see that. Mr. Divakar Pandey, welcome. Good evening. Area and volume calculation for figures, different shapes, polygon circle discussed as matter of revision. Welcome. Good evening. Thanks, Mr. Divakar Pandey. I thank you first of all because I'll forget otherwise. I should. Whoever says this is not easy calculation. We have to be very careful about. Thanks a lot. Thanks a lot indeed, Mr. Pandey. Divakar. That's okay. All right, now we go back and we see that. Well, we see that we're talking of app 29 and the application. I will say not other app, it's application. I am considering this formula as application actually. You can consider whatever you want, just for reference only it is. So we are going to combine this and with this. So what say? Subtract from octagon a pentagon. All right. Require 8-sided polygon, octagon, and 5-sided pentagon formula. So pentagon to be built into octagon. So what we got? We got 8-sided here, and this is our 8-sided formula, and this is our pentagon formula, 4-side formula. We have both. Here we have area of planar figure, and we have this area also, which is from direct formula, which you know, for every polygon there is a square into number of sides, that's in general, divided by 4 tangent bracket 180 over n. That's because to be taken into degree, not in radians. So this is the formula. A square, A means you can say dimension of that regular figure. A means that I'm considering A as dimension. A square into number of sides divided by 4 tangent, and that is angle. You know how many tangent degree? That's 180 over n. And if you divide 180 by number of sides, that degree gives you 4 tangent you take, and you get really a square meter area. So we have calculated here. So this both are telling, but we are interested in geometrical calculations, not in direct calculations. I want to use it for various purposes in quantification or somewhere else. That's why I'm trying to do more details on this. Once you do it, means this is for validation purpose only. The formula works here. So what we do, we have here all these details, and same as we did in last time, we'll now combine them rather than wasting time. And this combination of this means one inside other. This is our combination here. We call it combined calculations, and that is octagon, pentagon, both. Now octagon area is 1, name it 1, and pentagon area 2, and then we deduct 1 from 2. That's what is done here. Let's say J337. Let's say J337. That's this one, and here you know also pentagon area, that is I344. I344 is there both, and we deduct this from that, D348 minus D3, you got this one, exact area, net area. This is for square area, say for figure area. And now octagon, parameter 3, I name it 3 parameters fine for octagon, and the pentagon number 4. So we have parameter here C339, which is here. That's parameter of 1, parameter of octagon, and that's then C346. This is C346 here. This is for pentagon. So we can say that this plus this, because parameter shall be added. This is increasing actually. So it's this one. You see, Parameter here is, this is parameter, this is parameter. Area will be affected, surface area in 3 dimensions will be affected. That's the different one. So it also depends upon how much mathematics you know, and this is what is here now. We can say we got it, and now volumetric 3D calculation means octagon volume is this, so G339, this is here, G339, we have here G339, and volume, this is G346, which is here. Volume of both, we have volume of octagon and pentagon, and we deduct this one from that because this subtraction, we get net volume is this. Now 3D surface area for octagon, here we see surface area equation is surface area equal to all octagon surface area, all minus pentagon area. And similarly in pentagon, surface area is equal to 5 sides because 6 sides, 5 sides inside, extruded height we have, total surface area combination of these, we are subtracted solid. So what we do? We say all area here minus 2 into I344, I344 is here. We do that. So we get this one. This is for octagon and pentagon. This is 5 into dimensions in this, and this is sum of this we got. So we solve this problem as well. So we go to shape app 30, application 30, and which is this one, 1 octagon and 1 decagon. Octagon is inside decagon. Decagon is 10-sided here. 1, this 3, these 2, 5, and 5, 10. This octagon here. Octagon, 8-sided geometrical figure is within 10-sided geometrical regular figure, and that's where to calculate about. So what to do in this case? This is, app 30, combination of 8-sided polygon, pentagon, constructed in 10-sided decagon. This is what it is. So which says subtract from decagon and octagon, okay? Subtract from decagon and octagon. We have to deduct with subtract from decagon values, octagon values. So required decagon, 10-sided polygon, a decagon plus 8-sided octagon to be built into decagon. So we have here from by copying, because we already worked on that. So it is here, you can say. This is your formation or formula of 10-sided, and this is a formula for 8-sided, and then this is combination of these two. साईराम जी, हाँ जी ठीक हूँ। नहीं पहचाना, मैं नहीं पहचानता फालतू लोगों को, हम नहीं पहचानते फालतू लोगों को, और क्या, ओ बिल्कुल फालतू, हाँ और क्या, हाँ हाँ चल रहा है, अच्छी बात है, कूद जाओ, बीमारी खत्म हो जाएगी, और क्या।
अभी आ जाए तो ले जाएंगे, तो थोड़ा मैं मंदिर घूमे, घर में भी मन बड़बड़ाता रहता है, बैठे मैं 2-4 दुनिया हो गया। बच्चे के तो स्कूल बंद है, सब स्कूल तो काम को ले तो मांगे तो काम कैसा तो गाँव रहे शादी में
कॉम्बिनेशन
अब फिर जाना ये शादी इसकी बहन की बेटी की शादी मेरे को शादी लेकर रोना। और ये आपके बात तो इतनी शादी हो रही है, शादियों से आज की शादी है यहाँ पे इसकी एक बहन की दोस्त की बेटे की, मैंने जा रही है मासी तो मजबूरी गाँव की शादी है, जेठ की बेटी की शादी है, बेटी की भांजे की शादी है, सब शादी है। अब भैया पैर ठीक है?
कहाँ ठीक है, कहाँ ठीक है।
अब मेरी मम्मी है ना, क्या करे पता, पूजा करने गई, कमरा इतना बड़ा, पूजा करके उठी और वो वहीं पे उसकी पीतल की वो थी ना लेयर में फूल वूल रखे उसमें, वो थी उसमें पैर गिर गया, गिर गई। क्या कर गया हैं? पैर गिर गई, पैर उलझे उसमें गिर गए, हाथ टूट गई।
क्या करोगे?
वो तांबे का सागर हाथ में था, ऐसे करके एक गड्डी हाथ में थी, मैं दो चारों सामान ले रही थी, मम्मी तो मेरी गलती गिरती गिरती यहाँ पे चोट आ गई, ये हाथ हो गया। अब आप ऑफिस में ले डॉक्टर ऑफिस में हो गया, अभी नहीं कराया तो मैं कि अभी शादी है, शादी के बाद ऑफिस में कराएंगे। ऐसे ही लटका के रखोगे, जब तक ऐसे रखा था ये देखो क्या अंदर भतीजी शादी, अब 4-5 दिन मम्मी का वो भाई
खराब हो जाएगा अंदर ही अंदर,
हैं?
अंदर ही अंदर खराब हो जाएगा।
एकदम खराब है, ठीक है। भाई बोला कि आप क्या करें, मैंने कहा आज मैं गई।
मैं 12 तारीख को गिरा था, 14 को ऑपरेशन हो गया था एक।
हैं?
12 को गिरा था, 14 को एक ऑपरेशन हो गया था, 18 को दूसरा हो गया था।
नहीं तो डॉक्टर ने सलाह दे दी कि डॉक्टर टीचर ने भर्ती दे, डॉक्टर ने ऐसे कोई वो नहीं है, ऑफिस से बात कर लेंगे।
हाँ तो ज़्यादा नहीं होगा फिर।
थोड़ा ही है, पर ऐसे करके घूम नहीं रहा तो कोई इलाज ना ले, कोई इलाज खा लेंगे, वो पहना कपड़े पहना कौन सा ये वाला एकदम कहीं ना कहीं से ग्रह आ रही है, ऐसे कहीं से टूट के आ रही है।
ग्रह कहाँ से आ गई, दिमाग खराब करते हो। ग्रह विरह की बातें मुझसे ना क्या करें, ग्रह आ गई और ये आ गया, एकदम ग्रह बना देंगे हर चीज को, हर चीज को ग्रह बना देते हैं। ग्रह आ गई और ग्रह आ गई, कोई ग्रह विरह नहीं है। दिमाग लगाओ, गलती हो जाती है, एक्सीडेंट हो जाते हैं लाइफ में, क्या करेगा कोई इसमें। ग्रह आ गई है, जिस दिन पैदा होते तब ग्रह नहीं आती, जब शादी कर तब ग्रह नहीं आती है, तब ग्रह नहीं आती। यहाँ तो खड़ा भी
और मेरे ऐसे मेरे नंदे को परेशानी बहुत आ गई सर,
आने लगा था।
मैं तो उनके परेशान हो गई भक्ति भक्ति इन्हीं चीज़ों।
So deco 1 area 1, deco area 2, deco done 1, deco done area 2. आपको नहीं कह रहा।
भैया को देखते हैं
Deduction of this. This is one here, P361, P, 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 P.
उसे मकान खुलवा दे हैं, मकान खुलवा दे। वो क्या नाम है उसका, गुड़िया कहती हमारे तरफ आई थी मकान ढूंढते हुए, पता नहीं मिला नहीं मिला, फिर उसे कहती वो दिख नहीं रही, मैंने कहा मुझे भी दिख रही, वो छत पे दिखती है ना, छत पे तो नजर आती है, छत पे छत पे वो एक दिन फोन किया था मैंने छत वाले दिन, जब बोली ना तो फोन नहीं कर रहे।
P361 and here is J368, J368, this is here, and P361 is here. So we can add them, we can find them. Sorry, ये कुछ कर रहे हैं, क्या करूँ मैं यार। This one and this one, we deduct this one because that's inside. We deduct from this to this one, we got this one. And parameter also we got, and this parameter, decal parameter 3 and octagon parameter 4, and we take this one, add them, we got this one also. Because parameters to be added, reason is that it's here. This one and this one, parameters increasing here because figure inside, but areas decrease there. So that's one is, so we got parameter up. That's say parameters added and this is deducted. Okay, this is reduced and this is added. This parameter 3 name, this 4 name, this 1, this 2, and 1 minus 2, and this is 3 plus 4. That's one answer. And we go to volume, 3D volume, we go and we find about the how to find volume, and same thing is volume shall be deducted, shall be reduced. How shall we reduce in that? I'm just going fast because of this stuff in this video, sorry. Some people come, they don't know I'm making video, I'm just sitting, I'm not telling anybody, I'm just making so they don't understand, but I can't force them to stop. So it's a question of public, no problem. So this is area here, we got it. Now we talk of volume, the cogon, this is here, G362, this is G63, you know this volume here, right? And the other volume there, the 370. This volume and this 370, both volume are here, right? This volume is here, this volume is here, so we can say deduct this from that 374, and this we reduce 2, and we got this one, so we got 3 the volume here by deduction. Then area, surface area octagon is this. Why you say this? Because in octagon minus 2 into J368, this is all the column surface area minus octagon and areas. Remember, this figure requires that. This figure requires that. This figure requires that. This area and this both ends, because both ends have to deduct. That's the requirement of this, and that's why we say this is minus 2 into J368, and this J is this one. So we get this answer directly by this. That means surface area, 8 sided in the extruded height, 8 sided outside, inside, and we say total surface area of combination subtracted solid, and that is here. We can say sum of this and this surface area inside. There's 8 sides into extruded height. This 8 sides into extruded height, so this surface area adds to that one, and this happens here. So we got this cleared, right? We solve this. Now this is another one, and this is a combination of different figures here, different designs here. That's what we have to understand. Well, I think maybe it's not difficult, because this is total addition, but there are numbers there, various numbers. 3, one isosceles triangle, 3 decagon, and you can say 3 octagon, octagon, I'm sorry, again wrong. So what it says? Combination of 3 number, 10 sides polygon, decagon we call it, and 3 numbers, 5 sides pentagon, that is, and 1 isosceles triangle. If this is a figure, this is a figure, isosceles triangle, pentagon, and this is octagon, pentagon, isosceles, and this is also pentagon, octagon, and this is pentagon, octagon. No, this is all combination. There's no reduction here, all combination. Isosceles with 3 number decagon and 3 number pentagon. We have to combine them. It's easy and not difficult. What we need? Require 10-sided polygon. That's the decagon and the octagon and the isosceles. We are wrong, I think, is it? Maybe it's some error thing. What I've taken actually? I've taken 10-sided. I've taken here 10-sided and 5-sided. So it's okay, and I've taken isosceles. So it's okay, fine. Maybe there's an error in diagram. The error is actually should be 10-sided here. By mistake it's 8-sided, should be 10-sided, this one. This one should be 10-sided, this is already there, 10 sides, so no, okay, fine, I'll make a correction later. It doesn't affect your formula. What is there is 10-sided, what it says. All we need 10 and 8 and triangle. All are separately built, but connection, position, no subtraction. So we say this is 10-sided. This is 10-sided. Okay, this is 10-sided, and this is your 5-sided, and this is your isosceles, and this is your combinations of these. So let us see how to move in that. It's very important just to understand geometry and procedure, and that's what I'm trying to give you various cases so that you can assimilate procedure important, not method, no, not geometry. So sorry. We have area and volume here. It's area, and this will be verified here by normal formula, geometric, by formula of a polygon. And also we have here, you know, we have parameter, area into depth, volume, and surface area of 3D. And also we have here for polygon, same information, and we have for isosceles triangle, same information. You just copy, we got copied from previous records for purpose of combination. Now, what do you do? Combine calculations. This says, what it says, this is a little attentive, to be attention is required on this table. Okay, the members. The column, 3 numbers, then a little each decagon area of 3 decagon, then pentagon 3 numbers, each pentagon area of 3 pentagons, isosceles triangle 1 number, isosceles triangle area, and total area, that's area 1, area 2, area 3 is sum up here. Let's say combine calculation, 3 number decagon, 3 pentagon, and 1 isosceles are area A. Just a minute, please. Area A, okay. Isosceles. Oh my God. Area A. And this is 1 isosceles number area. Then 3 decagon, 1 pentagon, 1 isosceles number isosceles. And we can say decagon 3 and pentagon 3 and 1 isosceles. This parameter, this for area, this for parameter, this for volume 3D, this for surface area. This 4 we have. So we have numbers here. I will talk of this decagon. 3 numbers decagon we have. 3 numbers decagon. Now each decagon area 1 square meter, that is P385. This area, okay, P385. 3, this multiplied by this, you got this. I'm using product rather than something else. This into this. Then 3 pentagons, and this is here I391. This I391, and we got this. And this is again same product of this into this, and isosceles triangle is 1. This is 75, this is 396, and this is 396. Yeah, we got this, and you can say you got it, and we got this one plus this is 398. Sorry, this 398. So this one, I think The product of this we got 1 plus 2. What let this be sure is a sum of F398, F398, I398, I398 and K398. So we got this total area. Now we got perimeter. Let's talk about perimeter. So we got parameter. Let's say 3 number the column, same way as we did above. Reach the cone parameter 4, then you can say pentagon 3 number, same again as we did above, and 1 we did above. So we say C386, that's parameter. C386, it's here, okay. C386 is here. So take also here 300 multiplication of these two product. Then we say pentagon parameter, that's C93, C9, C393, and C393 is here. And then we got multiplication here, and same thing here we got. And sum of these two we can say. Sum of these two parameters, these 3, 4, 5, 6. This is 5, this is 4, and this is 6. Names of this dimension, this calculations. And volume. The column, 3 numbers. This is here 1, G386. This is this, yeah, G386. This is G386, and we got it here. And then this product of this and this. There's a pentagon. This is G393. G393. This is this one. Yes. G393 volume. And then volume multiplied both. And similarly we got 396. This is isosceles 396 here. G396. It's here. Just a minute. Maybe let me see if it's right or wrong. Each isosceles volume 9. Volume. Isosceles volume. This is volume here. This is L 396 actually. So we should be clear about this. If there's an error, we have to correct it. Each isosceles volume, 3D volume, and that is here. So it is, I think, end area into H, and this is this one. So we should say here G396, but actually it is 396L. So we have to see right also. If an error, we can correct it, you see. L396 is end area into H, that is volume open. So this is R1. This is isosceles triangle, and this is here 7 plus this K402, and this we can say this is total value. And then surface area, let's say again, this is for each, and this is for, you know, This is I386. I386. It's okay. It's okay. It's okay, fine. Then it's okay, fine, multi-practice. Then Pentagon surface area, I393. I393, that's okay, fine, it's okay. Multiplication of this, and this is polygon, this is not polygon, isosceles 3936 M396, and this is here, so it's okay, fine. So there's no error in this, and we got this one, and this is 10 plus 11 plus 12, that's 10 plus 11 plus 12, we got this. But to be sure about this is okay or not, once again, this is L396. This is each isosceles volume and L396, and it's okay, it's fine. So we resolve this whole calculation of 3. All calculation of 3 resolved, and I think it's after this 31 app. I think that procedure is important here. Procedure is very important. What we actually are getting ourselves involved with huge, major, complicated calculations, and once we start, I think if concept is clear, there is no bar to anything. What we have actually done so far, was that we started with many equations. We went on to many other formulas, algebraic formulas and trigonometrical formulas, and then we did all this, various ordinary figures, which are very important, though it looks very elementary, but elementary leads to compounding, You see these? Saram. Let me repeat these names. Maybe you can't see them clearly. It's better for me to repeat these geometrical figures, and that's here square. Then it is rectangle, and then it is after that equilateral triangle, isosceles triangle, right angle triangle, circle, cylinder, sphere, cylinder, cone, parallelogram, rhombus, trapezium, that is symmetrical, trapezium non-symmetrical, and polygons, 5, pentagon, this is hexagon, and then it is heptagon, then this is octagon, and this is nonagon, then it's decagon, and after that is triangle and circle, and after that it is combined right triangle and square, which is followed by combined triangle and parallelogram, and is then followed by combined right triangle in isosceles triangle plus teeth out right angle triangle. Then combined five-sided polygon, pentagon, construct a round square. Then, combined five-sided pentagon, construct a round isosceles triangle. The combined five-sided polygon, hexagon, constructed within 8 sides. And then combined five-sided polygon, pentagon, constructed within 8 sides, and 8 sides. This is yes. This is hexagon here. Here, this is pentagon. That's the only difference. But this is different. I'll show you sketches again. And combined sides, 8 sides pentagon, constructed the 10 side decagon. And then we just talked of combined 3 number 10 sides polygon decagon, 3 number 5 sides pentagon on one side. And if you want to see, just for references, I'll show you sketches, which is also very important. This is that one, and it's this one, other one, this is this one, and of course this is that one, which is all very important from clearance viewpoint or clarification viewpoint. And here you see them in our way. And it's very important to see. You can see likewise here, of course, very elementary diagrams as well. And that's what, basically what my objective is, to understand how can we move with computer system to, customize our calculation in the best possible manner. It's not necessary that we will find that everywhere, but method is very important. There is whatever kind of requirement, you can move yourself according to requirement. Not what I did, you do, no, not necessary. You do what is best. It can be whatever type of figure or diagram or sketch, but I'll show you many more cutouts. I'll give you many more shapes later, but you have to think of what's best way. We can do it. It is, after all, mathematics. Mathematics in worksheet, which is completely different. Mathematics calculations on worksheet are completely different. We have to be very clear about this. It's not what a spreadsheet can do. It's in a way how best we can make use of a spreadsheet. Best use in whatever way we can. It's very important. Of course, some formulas that are available on spreadsheet, Lotus 1, 2, 3 or Excel. Not necessarily use them. You have to extract compounding of formulas from those. Compounding of formulas. There are subjects, there are activities like quantity engineering, quantity surveying, value engineering, or designs. Wherever you can use it, it's being actually used, everyone is using spreadsheet for hidden calculations. And without which calculations can't be achieved. Only target is that we have to do what we can do. Best way, reliable way and accurate way. And it depends on really how do we understand about what we are doing. What we understand about what we are doing, and we have to do many more later, just like I actually, you can just delete so many here because I'm not I have some more calculations to do, and push down further, but still these are remaining to be done. For example, curves and here various equations, though I am going to concentrate more on figures yet, because I am working on AutoCAD also for those figures, because without JetCAD I cannot work out, because just without figures you can't understand. And for example, here we have, you can see, just like a plus b whole cube, a plus minus b whole cube. We have to entertain this also. And a plus minus b also with some other equation. Like that, I'll take up I thought to take more calculations. It depends on, but I think now you have an idea how to convert your cells into calculations. I could show you my sketches on AutoCAD, because I'm working on Excel. Same time, it's not possible on Facebook. When we share some screen, format should be same. I cannot transform immediately to other format. So when I have enough, many times last times I discussed with you many formula, though, which are on other computer, not on this. I'm working on different computer now. I show you many formula, normal formulas, like I show you again. For example, you can say this is this plus 1, and this means just pull it down again. Sorry. This plus this plus 1. So this is 1, 2, and we can go here. So we can, sorry, this is this way, yes. Formula is further copied, and we can go to whatever number, and we will automate this, and let us say, this is, though you may know this, but knowing is okay, but when we convert it to compounding, or you may say range, you may convert it to range. It's very important one. It looks very simple, but it becomes very complicated and useful. How? Let's say now I say that this is here plus last one. Let's say this one here actually. This is, let's say, plus go to last one and plus one. So if you just copy it, let me delete it here. You just copy it further, you'll find that see, it changes immediately. And if you do it from here to here, let us say I do this only, not the first one, and we'll get, you can say we'll get, let us say hold this one and we get like this. You see, you can see this, how fast it's moving. I didn't do anything except let me copy all except first one, and you can move very fast on calculation front or whatever data you have. Means it depends upon your intellectualism how much you can think on this. And let's say I now move all that and we stay here and do it. So you can say it has gone as 3 now. And let's say again, it's just a formula, it does wonders. If you apply formula rightly, it does wonders in calculation world. And you can see then, for example, I'm going here, this goes up and up again, and you can say automatically it works for everybody. And you see where we started and where we reached now. That's the only difference, you see. We have reached where? We have started, you see where we started 1. When you start, we started 1. Now, let's say again we take whole. Let's say we take here and we copy it and we go. And put it here again and paste it. So you got that. It happens. You see, it is crossed legs. It is crossed legs. So we may take from whatever column, and we can go to whatever column. There's no bar except formula should be there. So we can say we copy it now and put here at end, and let's put here and see how it works. And we can say, all right, well, it's disappeared, so I take it again. And we can see here. So you say we have reached around 300,000. Somewhere 300,000 be soon there in just 50 rows. So you can see we have reached 300,000. And this depends on how intellectually you can think about formula. And this is what I am stressing in, how to help it do its job. So you can say we started at 1 and we did. So that's what I'm saying. This is what I am saying. My intention is just to use a spreadsheet in its way and not in just in ordinary way. In an intellectual way, we should use it. Only in intellectual way we should use it, not otherwise. It can't be used for just small jobs. It can be used for all types of major jobs. So I would say now for today I will take it's already 1 hour 40 minutes, and I understand that you have got some understanding. I know you know very well before also, but because the short of time or because of some other reason, uh, you never tried, though you know everything. I'm just supporting, I'm just reminding and refreshing your memory that you should get understanding of such calculation power as I showed to you in this sheet, which is very normative to write, and let us see if I just let us see how it happens. Let us see some game on this. The game like is this. Let's say means. Oh no, I have to delete actually. I made a mistake. Yes. Now let's say we copy this. We copy and put it here. Say, let us see what happens. We copy and put it here. It happens. And if I add it here, last value is where? That's my point. Last value is where? Let's say last value is here. We have to go there. It takes time actually, but we have to go there and see. Let's go control home, control end. It's not going. So let's say let's see here. Now I want to go back here and see how it can. Control end is here, this end here, and this is that one. So I add this 3000 WC50. I use this WC50 to my work, and I say WC50 here. I say WC50. This is WC. I can say WC50 plus 1. Plus 1 is already there. And I say this is dot. So you see that value has started again. There was a there, now it started again, and where is it gone to? Let's see. It's gone to 60. This is 100. Yes, it's gone, and you can again, if you do that again, you'll find that this is what actually it is. We have to really control, and let me do. So here is end one. This is WC101. So I say here control home WC101. Let's say here. See, it's coming again, and 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 it's coming again. Yes, you are not doing anything, it's just moving on sheet, and it's giving you results automatically. it's giving results automatically. You are engineering only, you are engineering worksheet, and it's working like anything. It depends on your power of worksheet, how can you do it, and there is no limit. It depends. Maybe my worksheet stops now because of memory, I don't know, but it's already, it is gone astray, and you can say as if it's a printing automatically, but it's only method. I'm not saying you do it, not necessary do it, but if you do it, nobody can stop you. You can see that it's moving like machine. It's living like a machine. You can see where we were and we have reached where. That's only difference. We have reached, you can say havoc. We have reached as if we are flying. As if we are flying, and we are flying in fact. So we are flying. You can see we have reached millions.